Assalamualaikum and a very good morning. Thank you for your time joining my session, because today is very important where I'm going to explain to you and brief to you the two experiments in one session only. Okay, so I hope you pay close attention, because this experiment quite complex, that you need to understand the theoretical as well as the method to conduct step by step. So, my name is Dr. Muhammad Nur Hidayat. I'm from the fleet mechanic, right? Lecturer. So this session is recording now. So please scan first your attendance. In the meantime, we're going to take a break, and then I will show you again the attendance. Okay. So this is the rule and guideline. If you have any question, feel free to let me know. All right. Okay. Can we start? Can we start now, everyone? Are you ready?
Yes.
Yes.
Okay. Yes. So we begin with the flow rate measurement, right? I hope you can see my screen. So, can you see?
Yes, doctor.
All right,
Yes,
thank
doctor.
you. So, for today experiment, we begin with the flow rate measurement, which is we measure using the orifice meter, venturimeter, and rotameter. All right. So, the objective of today, which is to determine the actual and theoretical flow rate of water for venturimeter and orifice meter. Secondly, to determine the flow rate coefficient, which is CD, from the experimental data for a venturimeter and orifice meter. Okay, so this is the apparatus that we're going to use. The first, we use the venturimeter, orifice meter, and rotameter. That's it, the three equipment that you need to complete your experiment. So this is the theoretical background. This is all the explanation of the Bernoulli equation, okay, where energy cannot be created or destroyed, it can be transferred. So based on this Bernoulli equation, we use a lot of Bernoulli equation because the Bernoulli equation involves of the flow that consider different kind of energy. So here, this is the Bernoulli equation. Okay, so we have the pressure head, we have the kinetic head, we have the elevation head. Three terms for the Bernoulli equation. Alright, I hope you understand. This is just a basic of Bernoulli equation. Alright, this is the Bernoulli equation for 2 points. This is point number 1 and point number 2. Pressure over rho G. And this is the heat loss. Alright, so for this case, we neglect the heat loss. And this equation become this equation because this is simply equal to 0. Alright, can you see this from the Bernoulli equation? We assume this is negligible. There is no heat loss. So this term equal to 0. Okay, and then second one, this is the continuity equation in which Q equal to VA. This is 2 points. Point number 1 and point number 2. Alright. Based on the Bernoulli equation and the continuity equation, we combine equation of the continuity into the Bernoulli equation and form this equation we call as the equation number 4. And after this, we rearrange the equation of this into this form, in which we do the factorization, okay, in order to factor the flow rate. Can you see Q squared? All right, and then we realize that the pressure head and the elevation head is equal to the elevation. Okay. Okay, because of this one. Okay, this is due to the potential energy. Okay, and therefore equation 5 become, can you see this equation? And then we replace this term with H. You see here, we replace the whole this term, the second term and the third term with the H1 and H2. That is why the equation 5 become, alright, this term equal to H1 minus H2. The elevation at 0.1 minus 0.2. Thus, from this equation, we simplify further to get the value of Q, which is our flow rate. So, the square root equal to 2GA, this is the area, cross-sectional area to the flow. 1 squared area 2 squared, the change of elevation 1 to 2 over A1 squared minus A2 squared. Alright, so from here, we can get the flow rate. Alright, we do further simplification. That is why it is OR, where Q equal to area 2, the square root of 2G delta H, 1 minus A2 over A1 squared. This is further simplification. Basically, it is the same with this one. Alright, this term in terms of area. Alright, I believe it can make it easier if we try to change area into diameter, where area is directly proportional to diameter. That is why area we replace with diameter. Alright, the area of the circle, which is pi d squared over 4. Okay. So finally, this is the theoretical to get the value of flow rate, where A equal to all this term. Okay, so actually you going to use this term only. Okay, so based on our measurement device, remember we have Venturi meter. For the Venturi meter, you can calculate the TH, which is the theoretical volume flow rate equal to A2. It is the same thing here. This is the general. And, okay, the Venturi meter is the first parts of the pipe, H1 and H2. So that is why H1 minus H2, it is the same thing. Delta H1 to 2. Okay, so delta H1 minus H2, all these terms inside this square root should be positive. If you get negative, then you get the complex number, then you cannot solve. That is why this term is positive, H1 minus H2, and or divide with 1 minus the ratio of area. Okay, basically you're going to use the last term. For the orifice meter, this is the equation. You're going to use this term. Alright, this is the difference is for the theoretical orifice meter, you use the cross-sectional area at 0.7 and the H 6 to 7 as well as the diameter 7 to 6. That's it. Okay. So how to calculate the discharge coefficient? So you must know that discharge coefficient is the ratio of the actual flow rate over theoretical flow rate. Alright. So this is not the S. This is the A. This is actual. Okay. Typo here. So which QA is the actual flow rate? Accumulated fluid volume over time. So that means it's very simple. It is the volume over time. The actual flow rate. Alright, this is the explanation. For example, if 10 liters of water accumulated or flow within 30 minutes, therefore the actual flow rate can be written as 10 multiply 10 the power of negative 3. Because why? Because we need to convert into SI unit. This is liter. This is meter cubic per second. That is why we convert into SI unit. So conversion liter to meter, you need to divide with 1000. Okay. So this is the equipment. All right. So from here, okay, you can see point H1 and point H2. Can you see here? This is venturi meter and this is orifice meter. So this equipment we combine together. The first part we call a venturi because you can see the cross-sectional area reducing. It is venturi. And this part, it is orifice meter. It is the same cross-sectional area. But here we have the obstacle. So you need to consider this cross-sectional area. All right, this is reducing, this is increasing. Can you see here? Okay, it is sloping, increasing, increase gradient. So this is the methodology concept. Turn on the pump, start the position head until the appropriate air and water acquired at the manometer. This is the setting. So you need to start the test with maximum flow rate. Alright, this is very important. At this position, record the manometer scale and manometer reading 1, 2, 6, and 7 perforates. Alright, so you need to record this height at point 1, point 2, 6, and 7 perforate. Record the duration that is needed to collect the volume of water flowing. Let's say 10 liter. This is fixed. All right, we're going to give you the raw data, 10 liter, and then as well as the time taken for measurement. By taking the reading scale and the volume in liter, the data will be give the actual flow rate. This is the actual flow rate. Yeah. So that means you measure how long does it take for the water to accumulate for 10 liter. Okay, so repeat step C, which is step C here, until step D with reduced flow rate by adjusting the flow control valve. So that means you control the valve and you see from the maximum flow rate to the minimum flow rate. Ensure all the unit used calculation are SI unit. Okay, so
Doctor,
this is the result. Yes.
sorry for interrupting. Will you be uploading the lecture to the e-learning? Because some of my friends still can't join.
Okay, actually I have uploaded. If you look at the e-learning,
No, I mean the recorded the recorded class.
Yeah, actually the first beginning I already mentioned. This recording will be recorded and posted to the e-learning. Okay.
Okay. Okay, sorry, doctor. Thank you.
Right. Okay, the 6.0 result. Okay, for the result, you need to complete the table and plot the graph CD, discharge coefficient versus theoretical flow rate. So this is y-axis, this is x-axis. Alright, this is y and this is x-axis, the actual flow rate. This actual flow rate where you measured the accumulated volume 10 liter per second. Okay, this is per time for both venturi meter and orifice meter. Okay, so my advice, okay, you can use only one graph. All right, and then label it. This line refer to venturi and second line refer to orifice. All right. So this is CD versus theoretical value. Okay. So you can also do only one graph. Okay. For CD, because can you see? CD is y-axis, CD is y-axis, and the x-axis same flow rate. Flow rate. All right. You can make one graph. Inside the graph, you have three lines: theoretical flow rate, actual flow rate for venturi, and actual flow rate for orifice. Why you need to have in the same graph? Because we need to see the difference between theoretical and actual. So, and then finally plot the graph of actual flow rate versus rotameter scale. Find the equation from the plotted graph. Okay, this is the equation. So basically this equation you can get from, okay, you can get directly from the Excel file. Okay, show the equation for this line, you can definitely get. Or you can do it manually, where if the equation or the line is quadratic, you can use y equal to ax squared plus bx plus c. So plot and then find the 2 point, and then you can get the coefficient A, B, and C. Very simple. So discussion part, please comment the plotted graph. This is very important. During your discussion, please state clearly, alright, this graph A or this figure A, alright, this figure 1 refer to discharge coefficient with the actual flow rate. Okay, please mention the statement first. Alright, and then what can you see? The significant can you see? The actual line increasing significantly, decreasing. So second point, please state your significant finding. Alright, and the third and the fourth line, please showing the important detail. That means it is increasing, it is more than the theoretical, it is more than the actual. Please state the point number 3 and 4, you need to find the detail. That means you need to include the value. Alright, this is a complete explanation. If you give me the complete explanation of the graph, definitely you're going to have a very high score. This is very important. If you give me just sufficient information, then your score will hurt. You will hurt your score. Okay, so give me very detailed, sufficient, enough information of your graph. Okay, this is reflect to your scoring rubric. And discuss the problem of error. Okay, maybe your error, you need to discuss why your result is not the same as the a theoretical. Because of error due to the maybe of the air bubble, the flow rate not constant, you need to find it, all right? And explain why the discharge coefficient for orifice meter is far lower compared to discharge of the Venturi meter. You need to explain because of cross-sectional area. The cross-sectional area of the orifice meter is increasing. This is decreasing. Definitely, the flow rate will be higher from here. Okay, the flow, the velocity will be higher. So you need to explain as well as the loss. What the loss happened for the orifice meter and the Venturi meter? Maybe because of the change in dimension, reducing and increasing of the dimension will induce the losses. So you need to explain all. If you give me just sufficient information, so you're going to hurt your score. Please give me a lot of, you need to give me enough information of this. Okay, finally the conclusion. State the conclusion of the experiment by stating the mean of discharge coefficient. Okay, including its error for Venturi meter and rotameter. State also the conclusion, equation, and the graph flow rate versus rotameter. Okay, for this part, please please make my life easier. Where you state your conclusion, the below is the conclusion that we found from the experiment. Give in terms of point form. Alright, the first point form, explain what you get, what's the value of CD. The second point form is about the error. Please give me point form for the conclusion. Before stated all the point form, please make sure give the introduction for the conclusion. Give just a few 3 sentences for the conclusion, and then start with the point form. Give me the complete information. Do not give me just sufficient. Okay, so far clear? And one more thing, this you should use for simplicity's sake, please use the typing. All right. I give you 2 options. You can type and you can use your handwriting. If you this is important. If you type, please do not copy and paste because every report need to be scanned using Turnitin. All right, I'm going to compare with your friend. Please do not be same with your friend. Okay.
Excuse me, sir.
Yes.
For the graph, you can use Excel.
Yes, definitely.
Oh, okay. Thank you, sir.
Okay. So far, you understand the concept?
Yes, sir.
Okay. Let me open up the video of the flow rate. Okay. Can you hear? Can you listen, everyone?
Yes.
Slow, sir.
Slow sikit, Dr.
I can hear the voice, doctor.
Okay. So everyone, that is the video of how to measure the flow rate using the venturi meter, orifice meter, and rotameter. Okay. So for the data, okay, we're going to give you in the Telegram. So this is the, let me, all right, this is the data. Okay, the table that the first objective or for the discussion part, for the result, the first result, you need to fill up all these data. We're going to give you the raw data for the time. All right. For this QA is the actual. You can calculate by your own self where volume over time. Okay. And this is H1 and H2. We give you the data, the raw data. And for this part, you're going to calculate your own self. Okay. H1 minus H2. And this is the theoretical flow rate. Use the formula. Okay. What's the formula of Venturi? This one. This is theoretical. You need to find the H1 minus H2, just put into this formula, D2 minus D1, and finally you will get all the value for flow rate, theoretical. Okay, all this value. And CD. How to get CD? Remember, CD is the ratio of QA over QTH. You will get here. Please make sure your unit is consistent. If you use the SI unit, please use the SI unit. Okay, can you see this is liter? This is not SI unit. Please convert into meter. Divide with 1000. Alright, for the orifice meter, we're going to give you H6, 7. This one you calculate, and as well as this one. And this one. Okay. For this is the rotameter, we're going to give you the value. Okay, I think this is very simple, not so complicated. Once you fill up this one, please answer back your discussion. Simple. Okay, everyone. So we proceeds on the second experiment, which is the impact of jet. All right. So for today, for the second session, which is briefing of the second experiment, I'm going to explain and brief you the experiment entitled Impact of Jet. All right. So the objective of this experiment, the second experiment, to measure the actual force generated by water jet onto the first, a flat plate. We have the flat plate, and then we have the nozzle impact the flat plate. Secondly, the hemispherical cup like this, we have the nozzle with the water jet impact this surface. So we're going to measure the force, all right? So second objective, to compare the result of I with the theoretical result. Definitely we're going to compare the actual with the theoretical one. So the apparatus that we're going to use, the impact of jet apparatus, the flow rate tank, and the stopwatch. Very simple. All right, this is the theoretical background in which it explains the functions of this experiment. The force generated, all right, the fluid flow produce a force that could be utilized, all right. The force from the fluid can be utilized in the forms of energy. The force generates the fluid energy that can be used for the excavation of thin ore. This is the function, the applications of what you learn. And hydropower generation, all right? Rotate the turbine. So this principle applied in the race of momentum change, all right? So how the energy generated from the impacts of jet? Because of the principle of momentum change. Okay, so what's the momentum change? It comes from the force. All right, so can you see here, based on the Newton movement law, all right, this is the Newton's second law, F equal to ma, which is state that F equal to momentum change rate. All right, so basically this is F equal to ma. Why? You can see mass, this is mass, multiply with the acceleration, which is velocity divided with time. That is why ma. So because of that, acceleration, we can separate the velocity with the time we move to the mass, right? So now mass over time become the mass flow rate. That is why you can see the m dot. This m dot over time multiply with the change of velocity. This is the same with F equal to ma. So this is the proven of the dimensionless analysis, where the force is the unit of Newton. So what you need to know is the mass flow rate m dot, this is the indication, and the change of v is velocity, this is density, rho, a is the cross-sectional area of the flow, and the v is the flow velocity. Okay, this is the concept of the impacts of jet. All right, the left side is the nozzle. You can see basically we have the nozzle, and then the nozzle will emit or expel the water jet. Okay, this is the directions of the water jet from the left to the right. It is horizontal component. So, and then this is the surface having a specific angle. We don't know the angle. So, and then the water will deflect and move out due to this surface change. So now we have V1 and we have V2. All right. In terms of the x direction, the mass, all right, is actually, this is the mass flow rate, is actually rho AV. This is rho, this is area, and this is V1. So Fx, this is the force. Let's use the summation of force in the x direction. So this force acting to the right, it is positive, equal to this mass flow rate. This is F equal to ma. Yeah? This is mass flow rate multiplied with the change of velocity. This is V in. All right, where is the V in? This is a V in, inside, minus a V out. This is focused only the horizontal position. Okay, so V in is VI V1x minus Vx out. Vx out is a V2x. Okay, this is the horizontal. Why it is negative? Because it is to the left. Alright, it is negative. Because negative and negative turns into positive one. So, V2x, in order to get V2x, this is having a gradient, having the slope. So, in order to get V2x, you need to have the cos theta. So, V cos theta, you're going to have V2x. Okay. So for this case, we neglect any losses. So we assume that the velocity at inlet will be equal to the velocity at the outlet. So V1 equal to V2. So for this case, we replace the V2 with V1. You see here, V2 with V1. That is why V2 changed into V1. So mass flow rate is equal to V1. Can you see Ixx is actually the same? Only one horizontal component. That is why only one. There is no x, only one direction. We remove x. Plus V1, because V2 replaced with V1, cos theta. Alright, and then we factorize V1 and V1, we'll get these parts. Okay. Mass flow rate we replace with rho AV. Rho AV multiply with V, that is why V squared. And then left with 1 plus cos theta. For the y direction, this is the equation, the same thing. All right. However, we notice that the inlet velocity only horizontal. That is why Vy in equal to 0 minus V1y. V2y. Can you see V2y pointing downwards? When it is downward, that means it is negative. Negative with negative, positive. So you simplify, you will get mass flow rate V2 sine theta. Because why you need to put sine theta? Because V2 sine theta, you're going to have V2y. So from this case, you simplify further, you get rho AV1, rho AV squared sine theta. However, F2 will be eliminated, need to be eliminated. Why? Because you can see when we have the identical of the flow, so we have V2y pointing downward and we also have V2y on the other side, the identical side. That is why it is eliminate to each other. The bottom side facing downward, the top side facing upward. So we cancel each other. So Fy to be eliminated. So the final force, we only consider Fx only, which is Fx equal to all this term. Can you see here? Okay. So for your case, you consider two cases. The impact for the flat plate, which is the angle, is equal to 90 degree, where it is perpendicular and having the impact of water, which is 90 degree. Okay. And second case, you have the hemispherical cup, theta, with 0 degree. That means it is like this. All right. The same, having the zero angle. We consider as the zero angle. So you try to substitute the theta with 90 degree. For this part, you're going to have this equation. For the hemispherical cup, you substitute 0 to this equation, will become 1. So 1 plus 1, 2, multiply with this, you're going to have this equation. Okay. So this is how you calculate the, this is the general concept. For the theoretical one, as we discover, for the flat plate, which is rho AV squared, this is the density of the water, this is the cross-sectional area, and this is the velocity, right? So we substitute the value of rho here, which is the rho of water, 1000, and this is the cross-sectional area of the nozzle, all right? The nozzle having the circular shape. So pi, okay, pi d squared over 4. Can you see pi d, the diameter of the nozzle is 5 millimeter. Okay, that is why you need to divide with 1000 in order to convert into SI unit. So pi d squared over 4, this is diameter. Multiply with the velocity of the jet. Okay, this is v squared. So finally, for the theoretical flat plate is this value. Just use this value. You don't have to calculate all these things again. For the hemispherical cup, it is the same. But this cup, you need to multiply with 2 because we have the equation of this one. 2 rho AV squared. Okay, this is typo, this is 2 for the hemispherical cup. Because you look at here, 2 AV squared. Just substitute the value and then you're going to use this coefficient and velocity for the hemispherical cup. Don't interchange that. Alright, for the actual force, this is quite simple. You're going to measure the load impact, all right, the load change due to the impacts of water jet. So we give you the value of the load, all right. We have the load vertically upward, vertically position, And then the jet from the bottom will impact the load. And then you can see the change of load. So this load we give you in terms of gram. You need to convert the gram into kilogram. Why? Because F equal to mass multiplied with gravity. This is the weight. So weight, this is considered as the weight force. Weight force is equal to mass multiplied with gravity. So the mass we give you in terms of gram. Convert into the kilogram. Kilogram multiplied with 9.81 gravity. And then you will get the unit of Newton. So this is the methodology section where the first you need to install the flat plate and the nozzle. This is all the setup. And secondly, record the minimum weight by putting the load on the apparatus plate. So that means after you set up all the device and then you close the flat plate, close the cylinder and then put the minimum weight. And then adjust the indicator position. Come to the spring level. Okay, this we're going to see later on the video. That contain the minimum load on it. Switch the pump on and open the valve until the water reach the maximum. Alright, so that means we start from the maximum of the water velocity. Record the maximum weight by adding the load onto the plate until the position of the spring return to the standard level. Find the water flow rate. Take the time that is required for collecting 5 liter. For this case, we use the 5 liter for our volume flow rate. And obtain the weight range, alright? How to get the weight range, which is maximum weight minus the minimum weight. Reduce the total loads, okay, based on the range obtained from the plate. Reduce the water flow rate until the plate return to the standard level. And repeat step G, which is here, until the minimum load level, obtain at least 4 reading. After you get the weight range, you need to divide into 4, and then you know already your difference in terms of weight in order to get the 4 reading. So for this part, you need to exclude the maximum and minimum level. Replace the flat plate with the hemispherical cup. Okay, this is the second experiment. Okay, let's see the experiment. Okay, everyone. So that is the video for impact of jack. I believe you look at the last section, the last part where we're going to give you the actual load, the time, right? So you need to fill up. Okay, everyone. So from the experiment, what you need to give as the output first, all right? Plot the graph of practical force versus theoretical force of both analyzed system. This is important. Sketch in the same graph because we need to compare them together. And secondly, plot graph log Fs versus log V. Okay. And for the discussion part, elucidate. It means you need to give very clear explanations. Okay, the graph FA versus FT, this is the actual force versus theoretical force for both analyzed system. And then that means the system means the flat plate and the hemispherical cup. And secondly, from the graph log FA versus log V for both plate, you need to explain what is the form of graph obtained. Is it the quadratic, straight line, or vice versa? Is it form that you expect? Okay. If the form that you expect, please give the explanation. Why you expect this? Don't give, okay, this is my expectation. Please give me enough information in order for you to score well. And secondly, find the slope of every graph. You need to find the gradient. Okay. Compare and give explanation. Please give explanation why it is increasing, why the slope decreasing, why having the lower slope compared to the hemispherical. You need to give explanation because of losses, because of the change of the angle, because all the angle play very important role in reducing the loss, the friction loss. Okay, and C, compare the actual force between the flat plate and the hemispherical plate. Okay, this is the actual force. Compare between two systems. What is your conclusion? Please briefly explain completely. Discuss the value of theoretical force that obtained from both plates. Okay, this one you need to complete. All right. If the nozzle of the water, if the nozzle of the jet with bigger diameter is used to inject the water, what is the relation between the diameter of the nozzle and the value of theoretical force? During the experiment, is it steady or unsteady flow? How do you know? You need to know based on the experiment, alright? You try to find on your own, but I can give you when it is steady, there is no air bubble. Okay, there is no discontinuous. So that is part that you need to include in your discussion. State the factor which cause the reading obtained are probably not precise. This is the error. Okay, for the discussion part, please help me break it down. Okay, for the discussion A, please answer separately. For this part, answer separately because I need to give you the appropriate mark for the given discussion. Okay, please let me know. If you answer A, please remark that is A. If you answer B, please give me remark for B until F. Alright? Please do not give the complete of the discussion where I need to find each sentence one by one, which is reflect to A, B, C, and D. Please help me to give separate. Okay, once you do for part A, please give remark. This is A, B, C. Alright? And the conclusion, state the conclusion of the experiment. I need you to give in the point form. How to answer this conclusion? Refer back to your objective. Where's your objective? To measure the actual force generated by the water jet. So for this part, The above conclusion has been found, and here is the value for the actual force. For the flat plate, give the value. For this one, give the value, and you need to give your conclusion on the theoretical part. Give me in the point form so that your point form answer back your objective. Okay. So for this case, this is the standard. The nozzle diameter 5 mm convert into SI unit, and the load weight, which is we need to plus the standard weight plus the actual weight. For this part, we're going to give you the standard weight, all right, the value. All right. So for this part, the load weight, this is the load weight. We give you this value, right? Okay, I think you're going to have the actual weight, and for the load weight, you can see the standard weight plus the actual weight. So once you get the actual weight, you need to plus with this standard weight, and then you can have this load weight. So you can fill up this table and this table, all right? And for the F actual, you can directly get from mass multiply with the gravity. We give you, okay, can you see this is actual? Use this actual weight, in which, for example, this is 1000 gram. Divide with 1000 because convert into kilogram, multiply with the gravity. Then you get this actual force. For the time, we give you the time as well as the flow rate. Okay. So for the velocity, you can directly get the velocity, which is Q equal to AV, the flow rate. Okay, that is the continuity equation. Okay. So why you need the velocity? Because you're going to use in the theoretical force. You look at the theoretical force, it requires the velocity. You look at the theoretical force for the flat plate, it requires the same, the velocity. Okay, and then use your calculator to find this value, log V and F. And the same thing, you need to fill up for the hemispherical cup. All the same, okay? All the data, the raw data will be given to you. You yourself need to fill in the rest. I think that's all. Do you have any question pertaining to the two questions for this?
Doctor,
Yes.
what is the difference between the load weight and the actual weight?
Okay, basically the load weight is actually, can you see here? The load weight, the formula equal to the standard weight plus the actual weight that you need to combine. Okay. For the for the actual one, we give you the value. So that means this is more, a little bit higher lah compared to the actual weight. Okay. For the calculation one, you use the actual weight. Okay. Based on this. Okay. Any other question so far?
Saya nak tanya, in the report later, kita patut start dari mana? Like directly terus pergi results?
Okay, that is a good question. Now we proceed to the short report format. Okay, for your part, your submission, please include this cover page. Short report cover page. Where to get it? Please look at the website. Under the lab 1, then you can have this short report. Please attach together as the front part. You need to fill out the title, your semester, your detail, the experiment, and myself, my name. Okay?
Tapi kadang-kadang benda ni macam jadi terabur kalau letak balik dekat Words.
Okay, gunakan this function. Boleh tak? Can you use this function? My name, Abu. Can you?
Okay, so nanti kami try.
Okay, I think that is simple. My advice, do not convert into words. You can use this function. Fill up this using the sign form. Alright? Fill up the detail. For myself, I also fill up my name using the function here. Alright, this one you need to fill from the title until the lecture name. And for the last part, this is very important. Please follow the guideline. Don't waste your time putting all the theoretical explanation, because that won't give you any marks. Alright. For your report, start with this page, and then second page start with the table data collection. Alright. You need to provide only this. Your data collection. You need to calculate and fill up the whole table. So you fulfill the criteria number 1. And in order to score complete data, properly present the table, graph, table, figure, properly caption. That means when you put it in your table, your graph, please mention figure 1 refer to what? Figure 1 is the for example, discharge coefficient versus the flow rate. You need to mention clearly your caption. Otherwise, if you mention only figure 1, your data just sufficient. I will give you this mark or this mark. If you give me the enough information, I will give you outstanding. Very simple. So make sure it is clearly presented. Make sure if you use the same format, your time format, your text format, for example, the size is 12, use all the same 12. Okay, make your format consistent. Okay, this is important for the documentation. And for the analysis and interpretation, discuss what's required in this part. For example, can you see? For the discussion part, please, if you want to score well, please answer separately or give me remark which A, which B in your discussion part. I don't want you answer this form. Plus, please make sure make it one essay for the discussion. But at the end of the sentence, please state this is A. Okay, and then I can give you the score for this. Okay, and complete the analysis with good supporting evidence. Okay, this is important. If you think that the graph is increasing, why? Please give other suggestion, other researcher discovery, and put it inside your report. You need to have the citation. Okay, if you just simply restate what you have found, that means you get the low score. Very simple. It depends on you. Okay, and describe the relationship trend. Discuss the finding in relation to theory. Okay, as I mentioned, the first part in your explanation of the graph, please state what the graph is all about. Secondly, the significant trend. And the third and fourth, give the detailed explanation. It is comparable, it is dissimilar with the line 1 to line 2. Alright, please give me enough information. And finally, conclusion. You need to give me in the point form, answer back your objective. Then I give you this mark. Alright, so you should score 100 to get, you should score, the maximum is 100. Okay, please score above 75. Okay. So far, you clear about this? Okay, the submission deadline. I give you 1 week, 7 days to complete this submission for 2 reports. Alright, normally for the short report, only 24 hours, 1 day. But I give you a hefty amount of time for the 7 days and submit to the lab instructor. Okay, everyone?
Okay, Doctor.
Alright,
Okay, do you have any questions so far before we end our session?
In case ada apa-apa soalan nanti, boleh ke kami WhatsApp Telegram tu?
Yes, sure. I will post this recording to your e-learning, alright? Okay, for those unable to scan, please scan. The next, we don't have any meeting because I have explained to you two experiments in one session.